as we will just get started. So, as I said before, welcome everyone to our Dataiku Live webinar. We're really glad that you can join us today. And hey, let's face it, agentic AI is everywhere right now. Whether you're in manufacturing, healthcare, retail, finance, you're probably hearing about AI agents and wondering how they fit into your business. But before jumping on that agent bandwagon, we need to take a step back and really understand what's actually needed under the hood to make agents and AI work. So that's what today's session is about. We're going to highlight the modern AI architecture and what groundwork must be in place before you can really have value from agents and Gen AI. So I will go ahead and properly have us be acquainted. My name is Chad Coven. I am the host of today's session. I'm a senior technical specialist in product marketing here at Dataiku, and I've been with Dataiku for almost 3 years now. I'll go ahead and pass it over to Dmitri so he can introduce himself.
Hi, everyone. My name is Dmitri. I'm a solution architect here at Dataiku. Been here about 4 years now, and I'll be leading the product demonstration today. Nice to meet you all.
Yep. So right up front, where are we going today? First, we'll discover the powerful modern architecture behind today's most successful AI and agentic implementations, and we'll show you how a flexible framework can drastically reduce time to insights. We've already seen companies like Novartis experience a 90% reduction in time to insights using this approach. Second, we'll demonstrate how systematic evaluation of language models can optimize both performance and cost in a landscape with hundreds of available models. Knowing which one delivers the best results for your specific use case can make the difference between wasted resources and that competitive advantage. And finally, we'll explore how proper governance controls protect your organization from all types of risk, including financial risks for Gen AI adoption. And according to Gartner, most organizations will face cost increases of at least 40% for Gen AI by 2027. So we'll show you how to implement controls that maintain budget predictability without compromising security or innovation. So that's where we're going. How are we going to get there? First, we're going to take a quick stroll down memory lane and understand how we got to this current AI landscape. Then we'll explore the 3 critical points that most organizations face when trying to scale their agents and Gen AI offerings. Next, we'll see a live demo run by Dmitri in Dataiku so that we can understand how Dataiku solves some of these critical points. And finally, we'll go through a quick conclusion and leave some time at the end for questions. Also, I recommend for anyone that has questions during the session, please use the Q&A section. It should be all the way towards the right, right above the chat window. There you can type out any questions, and we can also type out responses. And if we're not able to type out a response to you during the session, we'll address them towards the end in the Q&A section. So let's start with that quick stroll down memory lane, as I mentioned, and we'll talk about why exactly we need this sort of modern AI architecture. So we all know that the tempo of AI's evolution is just at a breakneck speed. It is at a crazy pace. And this is not going to be an all-encompassing list, but over the past 12 months, we have had Anthropic release Claude 3 for their myriad of models. We had, not to be outdone, that same spring GPT 4.0 released. Then Mistral came out with their large 2 models. And then Google released Gemini 2.0 in fall of last year. Not to be outdone by DeepSeek, which essentially changed the world and was the talk of all the town for a couple months. Then Claude released 3.7 Sonnet, not to be outdone again by OpenAI 4.5. And then we had Gemini 2.5 released just a couple weeks ago. So we all know where this is going. What's next? So for IT leaders, this isn't just the timeline, it's really a challenge. Each release represents a pivotal point. You invest months integrating, let's say, Claude 3 into your workflows, and then GPT 4.0 arrives with capabilities that could benefit different departments. And as your team scrambles to evaluate it while maintaining existing systems, two more major models enter the market. And remember, these are just the headline models. We haven't even touched on specialized domain-specific language models or multimodal models that might actually deliver better results for particular use cases. So this relentless speed of LLM innovation we just saw, it really creates a fundamental challenge for scaling GenAI initiatives. Building enterprise solutions requires managing complexity across four interdependent layers that must work together seamlessly. First, the generative model layer, where what works best today might not work best tomorrow. Second, the feedback layer, where implementing effective learning loops across multiple models will compound complexity. Third, the deployment layer, which must integrate new models without disrupting operations. And the monitoring layer, which becomes increasingly challenging with each additional model and use case. So McKinsey's research shows that leading organizations are tackling this through component-based architecture, designing systems with swappable components that can be updated independently, allowing them to incorporate new capabilities without rebuilding the entire stack. And this brings us to the fundamental tension that organizations face: control versus innovation. Right? On one hand, you need tight control over cost, security, governance, agents, and LLM models themselves. And on the other hand, you need the flexibility to quickly adopt new models and compatibilities to stay competitive. So traditional architectural approaches force you to choose one or the other. Either you lock down your infrastructure for control but slow innovation, or you move fast but potentially lose control of cost and security. So this tension is at the heart of why scaling agents and GenAI has been so challenging. So when this isn't done correctly, let's understand some of the three critical failure points. The three critical failure points organizations face are being trapped in a rigid, inflexible architecture that can't adapt, lacking the ability to select the optimal model for each specific use case, and balancing performance and cost, and ultimately losing control over the security and the total cost of their GenAI and agent applications. So let's look at each of these a little further. Let's start with the first critical point: rigid architecture. When organizations build applications tightly coupled to specific models, they face the rebuild or fall behind dilemma. So according to IT Rex, this rebuild cycle triples development costs as teams must repeatedly reconstruct applications with each model switch. Meanwhile, industry leaders have already figured this out. Alganize reports 93% of Fortune 500 companies are using at least 3 GenAI providers for their applications, many of which are using 4 and 5 GenAI models and GenAI providers for each of their applications. The most successful companies aren't asking which model should we standardize on. They're asking, how do we enable an architecture to be flexible enough to use the best model for each specific need? Without this flexibility, you're constantly rebuilding rather than innovating. Number 2 is the failure point of model selection. Too many organizations default to whatever model is trending rather than what's right for their specific needs. But model selection is not just a performance issue. It's also a security issue. According to Harmonic, 8.5% of employee prompts contain sensitive data. So, selecting the optimal model might mean using a leading provider's API hosted solution for general tasks, but it might also mean using a locally hosted model when sensitive data requires enhanced security controls. The most successful organizations match each use case to the optimal model based on factors like data sensitivity, performance requirements, and cost. And without this strategy, we're either overpaying for capabilities that we don't need, or we're compromising on security for sensitive information. And speaking of security, the third critical failure point, which really is the most dangerous of all, is security and cost governance failures. We are currently in an environment where AI spending is outpacing IT budgets by nearly 3 times, while about 70% of executives admit to prioritizing speed over security. So we're watching organizations really create that perfect storm. This combination of unchecked spending growth and deliberate security compromises, they don't just threaten budgets, but they create vulnerabilities that could lead to data breaches and compliance violations, as well as AI and agents possibly going rogue. So the most successful organizations implement governance that provides visibility and protection while still enabling innovation. So now we understand the 3 critical failure points of ineffective architecture. So naturally, the success points are the inverse to have a modernized AI architecture. The first key is flexibility. As we've seen, models evolve at breakneck speed, so your architecture must adapt without requiring complete rebuilds. This means creating a foundation that connects new models to your existing layers without disrupting operations. Second is knowing the best LLM for each use case. This means systematically matching models to business needs, whether that's an API-based model for general tasks or a locally hosted solution for sensitive data. This approach optimizes both performance and cost across your entire architecture. Finally, maintaining full control over usage and cost balances, centralized governance with innovation. The right controls provide visibility and predictability while still enabling your teams to move quickly. So, what ultimately is the solution? And naturally, you will not be surprised. It is Dataiku. Dataiku provides the modern AI architecture in a few ways. First, flexibility is delivered through the Dataiku LLM Mesh, which creates a component-based architecture connecting all these leading GenAI providers you see here. This also allows you to seamlessly integrate and swap models without rebuilding your applications, which future-proofs your GenAI strategy against the rapid pace of innovation we saw earlier. Second, Dataiku's Quality Guard ensures you're using the optimal model for each specific use case, standardizing output quality while balancing performance needs with cost considerations. This systematic evaluation takes the guesswork out of model selection. And finally, Safeguard and Cost Guard provide the governance controls that prevent the security vulnerabilities and budget overruns we discussed. Safeguard reduces operational risk through security guardrails, while Cost Guard gives you visibility into GenAI spending and the ability to proactively block excessive costs, which is critical when AI spending is growing nearly 3 times faster than overall technology budgets. Together, this creates a modern AI architecture that delivers on all 3 critical success points. So now let's see what this looks like in practice. I'll hand it over to Dmitri to show us how Dataiku actually handles these critical points.
Awesome. Thanks, Chad.
So while Dmitri is getting set up, I'm going to go ahead and open a poll. We always love for some audience participation. I'll open a poll that you can go to the poll tab and vote, and Dmitri will lead us in our demo.
Perfect. Thanks, Chad. So what's amazing about Dataiku is you can leverage the platform to support a wide range of different use cases, whether they're GenAI based or not. But in this case, I wanted to start with providing a few examples of how you can leverage Dataiku to perform some of the most common types of GenAI related use cases. So for example, let's say that you are someone working in the insurance industry, maybe you're a loan advisor, and you want to have a really easy way to be able to have a natural language conversation with the underlying data sets related to your customers and to your documents. In this case, we provided an interface that looks very intuitive for the end user, somebody maybe on the business side, to be able to ask questions of the data. So for example, what's the average age of my loan applicants? And what Dataiku can support is this text to SQL paradigm, where any question the user asks can be translated into SQL and then answered in natural language by the LLM. And in the background, you can actually see what the SQL query was. You can continue the conversations. You can ask something like, and what's the minimum age of these applicants? And it'll go back and forth. It will generate another SQL query, generate a response, and provide it for the user. So now we have more users able to interact with that data through natural language that's automatically generated to SQL. Another example can be working not with just data sets, but with documents. So in this case, we have what's known as Dataiku Answers, a web interface connected to an underlying set of documentation for loan approval policies and our credit policies. And so I can ask questions of those documents, like what is our minimum credit score for approval, for example. And what's going to happen is it's going to automatically find the most relevant pieces of documentation. It's going to sift through that information, pass it off to an LLM, and the LLM is going to respond back again in natural language. And it's even going to cite the particular passages or documents that the user can see, that they can reference, so they can make sure everything is actually accurate in terms of what the LLM is responding to in terms of its answer. How great is that? And if you're looking for something even more cohesive, where maybe you have one interface, one-stop shop, where users can come in, they can ask questions of data sets, and it'll do text to SQL. It can ask questions about the policy documents. It can ask customer data set questions and so much more. That's when Dataiku Agent Connect is very powerful, because you effectively give this application access to a whole host of agents and their corresponding tools, such that the LLM can reason which tool and which agent makes sense for the particular task at hand based on the user's query. And so the LLM can then respond back with the appropriate information that is gathered from those agents and from those tools. In this case, answering questions about kind of a reference to our credit scoring guide. It will actually source which agent it used and which tool that agent used in order to provide this information. And again, you can connect up this agent with as many tools as make sense for the user's application and for the context at hand. Now you're probably asking, well, how do I actually go about building a use case such as this or others in Dataiku such that we can benefit from having this sort of interface for our end users? Well, let's go through it. So I will open up a flow in Dataiku, and I expect some of the audience are familiar with Dataiku, some less so. So I'll start off by giving a bit of an introduction. This is a flow in Dataiku verbiage, and the blue squares refer to data sets, as it were. And so we're developing like a pipeline or a flow that is representative of the use case we're trying to accomplish. In between the blue squares, you may see circles or other colorful objects. Those refer to recipes. So some transformation or typically some action we're taking on the data. And because of Dataiku's flexibility with respect to how you can work with data sets, these can be visual recipes, these can be code-based recipes, these can be recipes that are visual but call an LLM. And the idea is that whether you're technical or non-technical, whether you have a proclivity to working in code or prefer to work with visual tools, everybody has an ability to work with data in Dataiku. And so that leads to further collaboration, democratization of access to data and LLMs, such that companies get more value from these resources and from these models. Of course, if I'm working with structured or tabular data, then I can open up a data set here. I can begin to look at the distribution of the data, understand it, and begin to build out recipes to work with it. But in fact, in this case, we're going to focus on the RAG, or retrieval augmented generation section of what I showed earlier. So where the LLM can pull information from a set of structured or unstructured documents. And the beauty of Dataiku, again, is we can work just as well with tabular data and data coming from, say, a file share. So this could be a file share living in OneDrive or in SharePoint or in a bucket in cloud storage or on-prem. It really doesn't matter from Dataiku's perspective because we have connectors into various different data sources. And again, the data can be structured or unstructured. As you can see here, we're working with a few different PDF files that are within this folder. And we have tooling that's in place for the user to be able to work with this data in a very clean and easy way. So for example, we have what's known as this embed documents recipe, where it can point to a folder of documents like we're doing here. And it's going to go through each of the files within that folder, recognize the format of those documents. And for the cases where it's more of, say, image-like, so maybe it's a PDF file or a PowerPoint file, it's going to actually take a snapshot of each page of that document, and it's going to send it off to a large language model with the capability of understanding images, so a multimodal model, as it were. And it's going to ask the vision language model, in this case, the VLM, to provide a detailed description of that page. So this is the first place in which Dataiku's flexibility and optionality with respect to models becomes very apparent. You can actually select which model you want to leverage, which vision model you want to use in order to be able to make that happen. So as you can see here, I selected GPT-4o Mini, but you can just as easily select a Vertex model, a Bedrock model, an OpenAI, any of these other models. And again, the list here will depend on what level of access I have to as the user. So as a Dataiku user, your list might be different depending on what level of access your company has given you access to. So this is an example. And then for the cases where it's not a PDF or a PowerPoint file, if it's just text, it will simply send that text as is off for the embedding process, which is what's happening here. If we run that recipe, we are left with what's known as a knowledge bank, which is basically the collection of embeddings, a set of documents that we can then point to a large language model or an agent in another case, in order to ask questions of those documents. And the reason that this exists is because you don't necessarily want to have the large language model probe every single document and every page of that document if you're working with like hundreds or thousands of documents and they're really big documents. So the point of this is that at runtime, when you ask a model to ask questions of that data, it will go ahead and retrieve this number that you can specify here of documents, and then it will provide it as a part of the context or as a part of the prompt to the LLM, which again, you can specify which LLM you want this to be here. So now we're talking about which LLM is going to be able to connect to that knowledge bank and then respond appropriately. And you can specify, again, maybe you want this to be Claude, one of Claude's models, maybe you want it to be Bedrock, many different options available to you. You can even do local models that are downloaded via Hugging Face. We can go into a little bit more depth around how that can look. But the idea, again, is that we provide you that flexibility such that you're able to pick and choose using a dropdown which model makes sense for more use case. And you may be asking yourself, well, Dmitri, how am I supposed to know which model makes sense? I'm going to have to test this for every single model. Well, we actually provide a really nice interface to help with this. This is something called Prompt Studio. And within Prompt Studio, you can write as many prompt examples as you like, and send it as an example to the LLM of choice, and then get a response back. And that will be a qualitative way for you to be able to understand what that model is responding and if it's sufficient for your needs. So in this case, I have an example of a model that's Claude 3 Sonnet responding to my question of what is a typical approval process. I can ask a similar question using GPT-4o, which is what we're doing here. So I can run this. It's going to send that query off to the LLM. It's going to get a response back. And if I, have a few of these different prompts and I want to be able to see their results side by side, I can click the compare button and I get a comparison view between both of the models and what their responses were. So again, a qualitative means certainly for me as I'm developing this use case in order to get a sense of which model may be useful for myself in order to move forward. So now once I have decided on which model I want to utilize, then I can begin actually running it against a set of reference answers. So this is kind of like my ground truth, quote unquote, data, where I have some example questions that are sort of my gold standard questions. And then I have my reference answers, my labeled data that a human has written that I want to compare the results of the LLM and this reference answer really to see how well the LLM is doing against these gold standard questions. And so what I can do is I can actually set a prompt recipe, which I have here, connected to that knowledge bank. And I can say, I want for each of these questions in my list of questions, answer it. And I'm going to point it to a specific LLM. And I can mix and match between different LLMs here. I can also specify different settings with respect to giving examples for the LLM so it has a better sense of the structure I expect. You can also configure things like temperature and max number of tokens. We're going to leave that as is for right now. But as we go through this, as you can see, we get a set of responses. That is the LLM output that you see here. And then we're going to compare that to the reference answer that's provided. And the way that we do that is through this recipe that we see called the evaluate LLM. So this is the ability for us to more quantitatively assess how the performance of the model is doing. So if we take a look at the settings of this recipe, what we can see here is we can specify the input data sets. Really nicely, actually, Dataiku allows us to specify the type of task that we're doing as well. So you can see we have the option for question answering, summarization, translation, and based off of our answer to this question or to this dropdown, it will give us different options and different recommendations for the type of quantitative metrics we want to have as output. Because again, we had the qualitative view from the prompt studios, but now we want to make this a little bit more robust. We want to be able to actually take a look at some quantitative metrics that we can use for comparison between these different models. We'll also specify the ground truth column, which was our reference answer that you saw earlier, and then the metrics that are of interest for us. And these are out of the box metrics. So nothing that you need to do in order to be able to define these. Of course, if you're unfamiliar with what these terms means, we have a lot of documentation, both within the platform and within our actual documentation in our academy that helps to describe what the difference between answer correctness and answer similarity is. But if I take a few of these options as metrics to compute, then I'll be able to get a better, more quantitative sense of how my my model is doing for this specific task. If I have my own custom metrics that I'm interested in, then I can choose to apply it here as well. In fact, I've created a simple one here that's taking a look at the average cost per response. So I'm taking a look at the number of tokens, multiplying it by the cost per token for each of these models, and I'm getting a response as well. You can create your own custom metrics. We actually have some code samples for different types of metrics that you can see here that can help you to develop your own. But the idea is you can define as many of these as you like. You can standardize off of them for your particular use case, because again, some LLMs are better for some use cases, some are better for others. As we understand, as Chad has described, there's not one model that's perfect for every use case, and it is a comparison and a trade-off between performance and cost often. But if I run this this recipe, which I have set pointed to GPT-4o, I'm going to be able to do a comparison between how GPT-4o did versus other models that I've also applied to my standard set of questions. And so now I'm going to be able to run a more kind of cohesive comparison between all of these different LLMs. So as that's running, I'm going to head back to the flow, and I'm going to check in on what the result is. So as you can see, I've already applied this to 4 different models. So 4o mini, I've actually applied this process to DeepSeek model as well, and Sonnet 3.7, so the latest model there, along with o1, just for fun, because I wanted to see what the difference would have been between the number of tokens and the cost for a reasoning model versus a pure completion model. And I see GPT-4o just finished, so I'll refresh my page, and I should be able to see GPT-4o as well. Perfect. You'll be able to see graphs and information that correspond to these different models and their performance metrics. Of course, right now we just see one entry of the performance metrics that you see here, but over time, as you have the model go through different questions that may be asked, and this can be pointed not just to reference answers, but to actual questions that may be asked of the user, and then they can give their feedback back as well. You'll be able to see the performance metrics potentially go up and down over time, and you can use that information to inform whether or not you want to switch your LLM that you're using for your use case or not. So as you can see here, we have a few different model options available. The one that was highest performing from an answer correctness perspective was o1, but it also had, as you can imagine, the highest cost per response compared to these other models, which is of course not surprising considering it's a reasoning model. And so you have to make that trade-off. Is this use case, is that uplift between o1 and 4o worth the additional cost per response? I can't say definitively one way or the other. That's up to you as a user or as a business to decide. But if I want to dig into these metrics further and really understand for each question, what was the answer similarity? What was the BERT score? And what does that mean? I can open up the evaluation in more detail, and on a row by row, on an answer by answer basis, I can see what the output of the LLM was compared to the reference answer that I see here. And I can also see on the right-hand side here, the performance metrics associated. And keep in mind as well, these performance metrics, or many of them, are based off of the concept of LLM as a judge. So I'm actually pointing to an LLM that is taking a comparison between this reference answer and the answer generated by my original LLM, and that kind of referee LLM, or LLM as a judge, as it were, is making a distinction of what the score should be. So it's not going to be perfect, but over time, it's going to give you a sense or a direction of what the relative performance of these models are, especially if you keep that LLM as a judge consistent. Now, taking a step back, you're probably asking yourself, well, how easy is it to connect to these different models in Dataiku, and how do I provision access, especially from an IT or an admin perspective? How easy is that really? So I'm going to open up the connection window in Dataiku so that you can see how easy it really is. As you can see in this admin portal that we have for the LLM Mesh, we have options for connections to all of the major providers, right? Not surprising, we can connect to OpenAI, Cohere, Bedrock. We can host local models. We can connect to Mistral models, Snowflake, Databricks, etc. And the way that you can connect is very straightforward. For example, for OpenAI, all I need to do is put in my API key and then specify the models that I want to provision access to. And this could be a lot of different types of models. So maybe you want 4.0, maybe you want 4.5 preview, which just came out in o1, and maybe you want to turn on different models for embedding as well. And then maybe you also want to provision access at a per user, per group level, more likely. So in that case, you can specify which groups you want to have access to these particular models. And you can do that for OpenAI, of course. You can also do that, for example, if anyone's using AWS Bedrock, then with Bedrock, you can simply specify which models you want to have access to. We already have connections into their most recent release of their Nova series of models, but also to their hosted Anthropic. So Claude 3.7 Sonnet is already available in this environment, and of course, many others that you see here. And if you have your own custom deployment in Bedrock or other cloud providers, like with Azure OpenAI, for example, you could also bring them in here as well. So it's staying within your secured cloud environment. And then last but not least, if you prefer to actually work with your own locally hosted model, meaning either on-prem or in your private cloud environment, but downloaded via Hugging Face, then we also have this option to connect to a Hugging Face model. So I think I already have a Hugging Face connection that's set here. And all you need to do is add the Hugging Face API key, and then determine which models from Hugging Face you want to have downloaded down to your Dataiku environment, and then running on top of a Kubernetes cluster that has GPUs allocated. And with Dataiku Cloud specifically, we make that incredibly easy for you to get started with running Hugging Face models. Both from an infrastructure perspective and also from a user perspective. You can, of course, specify which models that you want to have working within your environment. We have numerous model presets that you can see here for different model families. So think Llama, Mistral, Gemma, many others. And you can also bring your own. So if you have your own model that you want to bring in from Hugging Face, that is not as a part of this list, but is available, simply add in the Hugging Face ID and it will become available to you. This is actually an example I gave with DeepSeek's 7 billion chat model. I brought it in and it's working within the Dataiku environment as well. One other thing I want to call out is for each of these connections that you are supplying for your users, as Chad mentioned, you also are going to want to have a set of guardrails for the ability to filter out potentially both at the query and at the response level what sort of information is being either sent to the model or is being responded back as a part of the completion. So you can add these guardrails at either a connection level or even more granularly at like a project or a use case level. But looking at this from a connection level, if I wanted to do things like filter for toxic contents, for example, I can add that guardrail to my Hugging Face connection. I can enable it on both queries and responses, and I can specify if I'm going to use the OpenAI toxicity moderation API or use my preferred local Hugging Face model as an example. If I wanted to add additional guardrails, such as if I have a data set that has a list of like custom forbidden terms that I want to make sure that doesn't never get sent out to the model, and if I want to also filter for PII or personally identifiable information, names, emails, addresses, phone numbers, this sort of thing, I can set that. I can filter for prompt injection attempts. I can also look to ensure or provide kind of a validity check around the response format if I wanted to always be as like a JSON format, for example. So these are all things that you can set at a connection level from an IT perspective, and then provision governed access for your users, your specific groups of users, as it were, so that they can have governed access over working with these models within the Dataiku environment. And again, making it as easy as possible using our visual recipes to be able to interact with the right model at the right time for that use case. We've talked about performance already with respect to working with these models, and you've seen with the evaluation recipe how you can effectively take the results of the models and then have it stored for the performance of your use case. Over time, as you begin to develop more robust kind of tracking mechanism for tracking the performance of these models, you'll be able to leverage our capabilities with respect to, say, scenarios and automation in order to be able to automatically alert yourself if the performance of your model drops below a specific threshold. So I can say if my model's answer correctness drops below 0.55, for example, automatically alert me as the owner of this project so that I can come in and review what's going on, potentially sub in a different model that's performing better, at least based on my reference answers or my prompt studios. But that's from a performance perspective. What about with respect to cost? That's a very important question as well when working with these models. Dataiku automatically logs every response and every completion that is being sent to and from Dataiku through the LLM Mesh. And as such, you're able to track both the performance, as you saw, but also the number of tokens and the cost of these models. And the way this can look is through something like a dashboard like this, where you'll be able to see the overall cost across all of your projects and all of your users and connections. Over time, you'll be able to see that are broken down by project, but you're also able to filter it. So for example, by a particular connection type. If I want to see how much I'm paying out to OpenAI, I can filter on this. And then if I want it for a particular project, I can do that as well. If I want to take a look more kind of holistically, of course, I can scroll down and I can see the total cost per project over time. So on a weekly or on a monthly basis, are we spending more or less on these LLM calls? Who are the users who are spending the most? So maybe I want to dig in further and understand who these individuals are and what sort of projects they're working on, and if the cost to benefit to ratio is worth it from their perspective. And then, of course, which provider we're spending the most on, because we have with LLM Mesh the option for as many providers as we like. But this is more of like a historical look at how much we're spending. What if I wanted to get in front of these costs? Because maybe we have a user who's going rogue and sending a lot of queries all at once. I want to be able to stop that before it becomes a really big issue. Well, with Dataiku's cost guard, you are able to support that. We have this concept called proactive blocking through cost controls, where you can specify specific, as many as you want, quotas for your models or for your projects or for your users, such that if any of those quotas are reached, you can take immediate decisive action. We have an example of a quota set here, where the logic is, if the connection is any of our OpenAI connections, or I can even make this more specific, I can say if the provider is OpenAI as an example, then I want the quota to be a max of $500 per month. And I want the reset period to be every month. You can actually configure that here, but I want it to be $500 every month. You can see the current cost, so you know how close we are to this quota. And then you can specify whether you want this to be a hard or a soft quota as well. So you can specify where, if that $500 is actually, a threshold is reached, block any subsequent queries from happening, such that there's no further queries being sent to OpenAI in this case. You can also make it a soft threshold, such that maybe I'll be alerted at a specific threshold, maybe 75, and then also at 100, I'll be alerted of that being breached. But our users are still able to make that call. But I'm going to for sure go ahead and talk to them about why they're spending so much on this connection. By the way, this isn't strictly at the connection level. You can set this to be by a particular provider, by a particular connection itself, or even for a particular user or set of users. So maybe we provision a specific level of compute cost or API cost for each of our user groups, and after that they run out. Or you can do it by project as well. And then at a, let's say at a production level, once you have these quotas available, you also want to make sure that it never reaches that threshold. So you can set as many of these cost controls and of these quotas as you like. so that you can be sure that your cost with respect to LLMs never goes above a specific threshold. And if it does, you can be alerted of it, and you can take steps to ensure that we don't spend any more than is necessary, so you can feel confident in your budgets as it relates to working with these models. Awesome. And then last but not least, I also want to call out the fact that Dataiku has governance capability baked in throughout the platform through our govern node. And what this allows for is the ability to provide a comprehensive view of all of the use cases that are leveraging LLMs in this case, and not just that they exist, but also who owns that use case, what model provider is being utilized. You can provide documentation throughout the govern node such that you'll be able to understand, what sort of intake process did we do, who approved this use case to happen. And so all of this documentation, and there's a workflow engine that's baked in to the govern node that you'll be able to leverage, such that you're going to be able to have full governance and oversight over any of these use cases I described earlier, whether it's text to SQL, whether it's an agent related use case, whether it's a RAG related use case. All of that can be cataloged and then set through an intake or a workflow process that you can fully customize and define, and provide the capability for sign-offs prior to moving into, say, a production state, and all of that being facilitated, I should say, through the Dataiku govern node. Of course, we'll dive into this further in a subsequent session or subsequent webinar chat, which we can give a hint to. But hopefully this gives you a good sense of some of the capabilities in Dataiku, solving for those three key pillars that we described earlier, with respect to flexibility, knowing the right LLM for each use case through evaluating their performance metrics, both qualitatively and quantitatively, and having full control over the usage and cost of these particular models.
Totally. Thank you so much, Dmitri. That was a fantastic demonstration of Dataiku and how we solve for those three critical success points. Just to round everything out, I'm going to go ahead and share my screen just one more time for old time's sake. And then we'll go ahead and hop into many of your guys' questions. So we covered absolutely a lot of ground today by exploring those three critical factors for a modern, successful AI architecture. So I'll leave you with the three takeaways that we talked about at the top of this session. First, a modern AI architecture powers both your agents and GenAI applications while dramatically reducing your time to insights by up to 90%, as I spoke about earlier. So organizations that implement flexible component-based architectures avoid the costly rebuild cycles we discussed and can adapt quickly as models evolve. Second, systematic LLM evaluation is no longer an option, right? We need it to be mandatory. So by implementing a strategic approach to model selection, you can optimize cost while simultaneously improving performance for each specific use case. And this balanced approach really ensures you're using the right tool for the right job. Lastly, proper governance controls provide dual protection, safeguarding you from unexpected cost increases as vendors' prices are changing, and you maintain that robust security protocol that protects your organization from sensitive data. So the bottom line is this: moving from reactive, fragmented approaches to a cohesive AI architecture is what separates organizations that merely just want to experiment with GenAI and those that can actually put it in production and have it transform their business. So thank you all for joining us today. Dmitri and I are happy to answer any of the questions that you have. I see there are a ton of questions in the QA section, so we do appreciate you all. So we'll go ahead and start answering them. So one that I have not addressed via chat is, You showed the user selecting a model from a dropdown. Any thoughts or plans on dynamic model selection, meaning based on the use case and the context of the request, route to the most appropriate model to respond to that request. Most appropriate can be most accurate, most fine-tuned, lowest cost, lowest latency. So in our roadmap, I don't believe we have any sort of plans of creating, dynamic model selection. But I do think that's a very interesting use case that can definitely be done in Dataiku. Dmitri, I don't know if you want to expand on that.
Yeah, so I actually can see it being done through agents. It would be some work to define the flow such that you're able to accomplish this. Because essentially, if you wanted to do it quantitatively, you'd have to be able to execute a process to run like an eval recipe against that model and generate the performance metrics for some set of data, and then have an agent essentially have a tool be able to pick up that information and then respond to the request from the user dynamically based on the results of that evaluation. So technically, it would be possible. Not something, to Chad's point, we have out of the box today, but certainly doable with the extensibility and the flexibility of the Dataiku platform and our agent features.
Yep. All right. So moving forward, we also have a question about verifying my model quality. Can it be one shot for qualitative comparison as well? So when you say qualitative comparison, I get the understanding that it's, looking at these answers or these responses side by side, or even having the LLM as a judge kind of look at them side by side and provide to you some sort of, answer. And that's yes. I think Dmitri showed that off during the demo within the evaluate recipe. You can see the row by row analysis. And in this demo, we showed just text. That's also the case for multimodal. So if you were looking at images, in the near future, you will be able to see these images side by side as well to understand how these models are processing. So yeah, there's that. We will continue through these questions. Somebody said, in other words, there is no need to fine-tune LLMs in Dataiku as various models are available as per use case, correct? And Dmitri, I'll go ahead and pass that one to you.
Yeah, we don't want to say blanket statement. There's no need to fine-tune LLMs because there is some valid reasoning sometimes to fine-tune models. And in fact, in Dataiku, you can fine-tune LLMs through our interface, either through code or through visual recipes. So that is a capability that we provide. But you are right in the sense that the more options that you provide for your users with respect to different LLMs, the less likely it is you'll need to fine tune, because it'll be less work just to pick and choose the right model for your use case versus going through the process of fine tuning. This is true.
Okay. Moving forward, will Dataiku provide customer support initially until the users become acquainted with the Dataiku UI and infrastructure? Yes, that's something that we definitely do. We are big on our services, and we offer many different services to make sure that our customers are up and running smoothly and can actually generate value from Dataiku. So we have, data scientists, we have use case ideation, we have field engineers that'll get you up and running in terms of infrastructure. So there are many different ways that we support our customers once they become Dataiku customers and make sure they're up and running smoothly. Which agent framework do we support? I think I may have answered this one, but on the back end, we support LangChain as well as LangGraph. So you can create agents visually and with code. There are webinars that we've done previously that show that off. There's also a webinar that's coming up, which I'll highlight in just a little bit. That'll show that off as well. How do you compare your offering with Azure and AWS?
Yeah,
Dmitri, I'll actually pass this one off to you since you work a lot with our partners.
Yeah, it's a very fair question. I would say that, Azure, AWS, they provide a lot of different services and different offerings. Typically, we actually partner with them. We can deploy Dataiku in your preferred cloud and run Dataiku along with connecting to various services that those companies provide. So, for example, for Azure, it would be like Azure OpenAI or working with Synapse or Fabric or other services. And then with AWS, it would be similarly Bedrock, SageMaker, Redshift, etc. They also have, to a degree, their own capability with respect to working with, of course, LLMs and also doing data processing and machine learning, but they are all their own, I would say, service or product within that suite. So Dataiku is unique in the sense that it's holistic. You have one product that does all the way from data access, data prep, all the way through to machine learning, working with GenAI models, and then the governance and auditability around all of that, as like we showed you earlier. And what's more is that our interface is supported by both coders and non-coders alike, so that you have flexibility with respect to how you're working within the environment. You can certainly try to make a comparison, but I would argue that we are quite unique in the market as it relates to our offering.
Totally, totally. I would definitely agree with that statement. Heading to the next question, can the Dataiku tool suite work with an in-house hosted LLM versus the commercial LLMs? Yes, we definitely can. We showed it a tiny bit in the demo of working with a locally hosted Hugging Face model, that model being DeepSeek, but it could have been really any model that we wanted to choose, whether it was an open source model like Mistral, or if you had your own locally hosted model, we could definitely use that through that connection to be used in your flows and in our visual recipes and whatnot. We have another question. We have standardized on Red Hat's OpenShift for Kubernetes. How does this factor into implementation of Dataiku? Is this a problem? Dmitri, I'll pass that to you.
Yeah, no, it's not a problem. We work with many customers who are leveraging OpenShift for their Kubernetes cluster. We would integrate and support that connection. We would use like the base Kubernetes process. And we would be able to, for example, run a Hugging Face model leveraging that OpenShift Kubernetes cluster, along with many other processes we can do on Kubernetes.
Awesome. Awesome. We have one final question. We are exploring how Dataiku can help us evolve it with AI ML, including automated score analysis, natural language report generation, coaching workflow support, and research assistance. Can we get a personalized demo later sometime? So I would definitely say reach out to us, and we can definitely get something set up with one of our fabulous SEs. Or one of our CSEs, depending on your account. But yeah, I would definitely say reach out to your customer support team, and we can look at making that happen. Last but not least, do you support creation of MCP server? So from my understanding, not currently, but that is something that's on the roadmap that we are definitely thinking about. So when there are any updates around our integration with MCP, we will definitely let you know. Real quick, before we go, that seems like all the questions. I just wanted to make everyone aware that we do have another webinar coming up next week at 11 a.m. Show and tell inside the agent toolbox. So we didn't talk about agents a lot today. We referenced it, we showed it off a little bit, but we didn't dive in. This will dive into agents. So if you are interested in agentic technology, definitely come back, and you will see agents in all their glory in Dataiku. So thank you all for joining, and you will get a recording of this very soon. We appreciate you all and hope you have a great day.